join discord.gg/flatearth and enter a check-in room. Someone will come along and verify you to get involved in the conversation about our Earth.
Fresco.
I was gonna say we got a new person, Fresco. Are you there? He's kind of muted, but we can talk to you.
I'm not that new.
Oh, okay. You already know. I mean, what do you believe the reality that you're in? Like, do you think the Earth? What do you think about it?
It's a globe.
Okay, so you still believe in the?
I've had this talk before, and yeah.
What leads you to believe that?
Yeah, give us your best reason. Number one
I've already done this a few times. So
we still haven't seen any proof, though. So we're still wondering.
It's just give us your best.
It's for us. It's more for us. Than
we want to know. We want to know.
What do you want to know? Why I think it's a globe?
Yes.
There's a lot of reasons why.
Pick one.
If I start talking about this, it's going to take ages.
You can talk about the image. I mean, I could give you a million. Well, how about this? Let me ask you a different question.
What about the moon?
What about it?
What about it?
Do you think people landed on it?
Yeah, well, I do think people landed on it.
Okay. Let me ask you this.
That's not what I meant. Yeah.
Oh, sorry. Go ahead. You wanted to say something?
I didn't mean like people landing on the moon. Like I wasn't using that to show that the Earth is a globe. But I just mean like.
Okay.
There's a few reasons like.
Yeah. Let me ask you this. When it comes to the moon landing, the moon, in order for the astronauts or so-called astronauts, let's say, in order for them to walk and jump on the moon, there had to be this thing called gravity on the moon, right? Like
it was like gravity on the moon. It's just not as strong.
Okay. So right. So in order for the moon landing to have happened, the moon needed to have at least some, maybe not as strong, but it needed to have this. There's this concept called gravity, right? That needed to exist, right?
Yes.
It does exist. Yeah.
Okay. So now gravity is that's like the linchpin. Actually, that the concept of gravity is really the glue that holds the entire cosmology together. Like all the solar system, the galaxy, the fact that the Earth could be, or could possibly be a sphere, space travel, all that stuff, right? It all comes down to the fact that they need this thing called gravity, right? This thing, gravity, right? They have to have it, right? Have you ever been? Here's my question: have you ever been questioned, like as far as the proof goes, like the scientific evidence of gravity? Have you ever questioned it?
What do you mean? Like, have I seen? What type of proof do you mean?
Okay. So, like, for example,
because you
scientific.
Yeah, scientific evidence.
You guys don't really like. If I give you some equations or things like that, you don't class that as proof.
No. If it follows the scientific method, it has to. Basically, it has to follow the scientific method. Are you familiar with that?
It's very hard to convince to convince a globe through gravity.
I've already done this. I don't want to have a long.
Because you need videos. You can't see the green screen. So you can't see.
Go ahead. You guys got this. You can take
over. The claim of gravity goes that this thing called gravity formed the Earth into a ball in the vacuum of space, right?
Yeah.
So can we get a look at this ball that gravity made?
What do you mean?
Can we see the
What did you
ball that gravity
I didn't
made?
hear properly.
What's that?
What did you say?
I want to see the ball Earth that gravity made.
The ball Earth that gravity made.
Yeah,
You're
show it.
You
standing
want
on
to
it.
see the Earth.
No, I don't want to see the Earth. I've already seen that. I want to see the ball Earth that ballers keep talking about. I haven't seen that.
There's so many pictures of it, but you don't believe that they're true. They're real.
Do I have to believe them, or are they verifiable?
Well, all pictures you can say you can't believe them until you see them, can you? So how are you ever going to believe anything if you won't believe it until you actually see it?
Those pictures
Yeah,
are
exactly.
alleged to be of the Earth, right? And they're showing curved bodies of water all over the surface of that thing. When I go to the beach, I don't see one of those. So that picture cannot be what I'm out looking at on the beach. Cannot
Well,
be the Earth.
obviously, when you're at the beach, you don't see it because it's huge.
Yeah, but that would be, assuming that I didn't take into consideration the claimed dimensions and scale of the globe, which I did. So I don't see what I should be seeing. I don't see the curvature at the rate that it should be if the Earth is that thing that they're showing in those pictures.
Okay.
Yeah, that's not being seen. We don't see that.
She has a point though about the picture thing, because you're saying you'll only believe it if you can go up in space. Because if you'll take someone else's pictures but not NASA's, then you're a hypocrite essentially. Like there's no, if you won't take NASA as a verifiable source, then you can just, like, anyone can make up any kind of source essentially. So you would.
The question is, like, can we verify these images, or do they just have to be believed?
No, of course they don't have to be believed. But I'm just saying, like, her logic. That's how. Like that's what.
Yeah, I'm asking her if there's any verifiability for them, or if they just have to be
But
believed.
that's the same with every single picture, ever.
No, it's not. It's not really, because that's an extraordinary claim to say, hey, here's the world. It's this spinning ball that you don't experience, that you've never experienced. Hey, dude, trust me. That's an extraordinary claim. That would be like me presenting an image to you of a unicorn and being like, yeah, I saw this thing in my backyard. That would be an extraordinary claim. So that's the kind of picture that is, right? But if some dude takes a picture of a lake, at the beach, that's not extraordinary. So that's
you've
not
already
in the
seen
same category.
that before because
That's
you
not
can
in the
go
same
to the lake.
category, though, as a spinning ball Earth from a vacuum of space that violates thermodynamics, right? That's just an everyday thing. That's just a dude taking a picture at a beach. So those two images are not comparable.
I have a very easy example about gravity. When if you are your weight is 50 kilograms, for example. If you go above the hill, what's your weight will be? Should be a little bit more, right? Because
If you what?
a little bit less.
You're gonna kind of take it into the weeds with her, I think.
No.
What it all comes down to is that gravity was supposed to have made this ball Earth, right? And for proof of it, we have pictures that cannot be verified that do not match the ground that we're standing on when we go and look at that. So what do we have really for this ball Earth story?
If what is your name? Heretic.
Yeah.
If your weight, for example, 80 kg, and you go and you went to the Everest, and you scaled, you take the scale and you want to see your weight, should be a little bit less because you are a little bit far from the center of gravity, right?
Yeah.
But your weight is the same as it's anywhere down.
It's kind of a derivative thing, though, because we don't have any evidence of the ball in the first place to think that there's a ball doing anything to my weight, the further high, up I go or whatever.
Yeah.
But your form of evidence is actually seeing it. So how would you ever have evidence without going into space? That's the only way.
You can measure.
So wait a second. Either you've gone to space or you don't have evidence. You just have a blind belief.
Exactly.
No, I'm saying your view of evidence is by actually seeing it. Like you guys weren't
Okay, but your view of evidence doesn't entail actually seeing something. So what's your idea of evidence then?
Well, there's a lot of forms of evidence. Like obviously, would you not class a picture as evidence, a photo as evidence?
It's not verifiable. It's not evidence. And it's also falsifiable, because like I said, they're showing curved oceans and they gave us a radius and everything. So we can check the Earth to see if it has those. Go ahead.
So what? Okay, so imagine the Earth is actually a globe. Like, say it actually is a globe. Then how would you ever believe it if you can't go into space? But it actually is a globe. Hypothetically.
Okay, so I'm hearing that it's just a belief then.
It's religion. It's a false religion. You just believe.
Yeah, which is fine. I'm not knocking you for it, but we're just elucidating that that's what it is. It's a mere belief. It's not something that can actually be demonstrated in reality. It's just something that you have in your head that you think.
Okay.
Okay, let me ask you this, Fresco. Have you seen all the observations, like the long distance observations, and like how?
I haven't really gone into it that much.
Okay, but have you heard about them in the server? Like any of the channels, like the laser tester?
What do you mean, like when you guys look at the boats on the horizon, that sort of thing?
Okay, that's one. But yeah, okay. So have you heard about that? Yeah. What do you think of those?
Yeah.
Tell us what you what do you remember about that discussion? Yeah, tell us.
Someone was saying that you can still see the boat, but you shouldn't be able to see it due to what the supposed length towards the horizon is.
And okay, yeah, it has specific distances, right? There was numbers, right? Okay.
Yeah.
So, and those numbers were based on the radius. Are you familiar with the radius?
Yes, I know what a radius is.
Okay, so let me ask you this: in 10 miles, how much curvature should there be?
I don't know. I don't know that.
Okay, it's okay. We can give you. Have you heard the formula? Do you know the formula for the 8 inches per mile squared or 1.22?
Can we back up real quick? I just want to. Yeah. I think it's a bit too fast. Because you said, if we don't go into space, then how can we know, it's not a ball, hypothetically speaking, right? Like, I mean, that's like saying, well, if I don't go to Narnia, then how do I know Narnia doesn't really exist? Well, what's the problem with me saying that?
Well, sure.
Obviously. Well, Narnia is on TV, right? And we know Narnia is fake. Okay. So when you think about space, okay, there's a vacuum. Okay, there's a vacuum next to air.
Yeah.
Okay. So that's the problem too. We know that that's not possible. Yeah.
But I'm just saying that's what you guys want for evidence. You want to actually see it. There's no other way that you would
don't really
want evidence.
Yeah, but the idea of going to space, that's not what we're asking for. We just want the thing directly measured.
Yeah, the evidence is already in front of us because we're told to assume a non-rotating plane. Okay.
Wait, why don't we measure it? Why didn't the people claiming it's a globe measure it?
But you're the one that thinks it's not a globe, so measure it to see.
Wait, so if they never measured it in the first place to claim that it's a globe, then why are they going around saying
that? They've got other evidence for a globe that you don't believe. So if you don't believe it,
what evidence is that? Well, I have evidence that Narnia is real, but you're not going to believe me if I show you. Okay, there's a movie.
You guys
called The Wardrobe.
Feel very strongly about this topic. So why would you not measure it?
Because it's not our claim.
We have measured it.
Claim that it's flat.
Yeah, we have. But the thing is, why does it? But wait, that's a burden reversal, though, right? Because you're in here saying it's a globe, and you're like, "Well, go measure it for me."
I know, but you're telling me to go measure
it, right?
it.
Why wouldn't the people?
Let's say we measure it.
People who say it's a globe have done the measurement to support that, right? Why would I have to be the one to get
How
the
would you
measurement
wait?
for someone else's claim?
Stop. It's not about anybody measuring it. How would you measure? Like, think about a basketball. Okay, we want to know how big that basketball is, the radius of it, right? How would you measure it? How would you acquire that information having the ball right in front of you? The basketball. Okay, let's say we're going to measure the curvature rate of this basketball. What would we need to know first to build the right rim to fit it in? Basketball rim. We'd need to know the radius, right? How would we measure the radius of this basketball then? This is an easy example, right? Should be really easy. The basketball is right here in front of our face. We can measure it physically.
Well, do you have any suggestions as to who and how measured it, Fresco?
Right?
No.
We know the basketball is round, right? We can see it. We know that water does not do that. We know that. We know water is level and flat. So how can one measure curvature on a flat surface? Flat leveled surface. So let's ask the question: who has
if you're
done
not
this?
open to it being a
Right?
globe, then
NASA must have 100% have done this because this should be done. Science, bro, right?
well, they don't
But guess
really
what?
need to
They
do it.
don't.
I mean,
Well, they
they
don't
can
need to
find
do it, but I do. I need to do it, but they don't need to do it. What kind of stupid is that?
We need to go find the evidence for their claim for some reason. How does that make sense, Fresco?
But they've actually gone into space and they can see it.
And you know that
how
because
do you
they
know
said
they've gone
so?
into space? How do you know I haven't gone to Narnia? How do you know that I have not gone to Narnia and have proven Narnia to be real? How do you know that? You don't. You don't know that.
Yeah, you could have gone to Narnia.
Just like you don't know if they've actually gone to space. Just like you don't know that the Earth
why
is
don't we
not a
ask
ball.
her? Why don't we ask her if she knows, and if so, how?
Go ahead. How do
Do
you
you know
think
that
it was
they've gone?
done? How can it? Yeah. Name one way that we can prove it.
Well, the only way you want to prove it is by measuring it or going into space, is that?
Okay, let me ask you a question. Do you agree? Do you agree that it looks flat? Yes or no?
Yes.
You agree it looks flat. Okay. So there was Neil deGrasse Tyson at 128,000 feet. Even at the ISS, he says that stuff is going to look flat. You don't see the curvature of the Earth. Then how can we measure it, right? If it looks flat and is assumed to be flat, then how can you measure curvature? You can't. That's the answer. There's no curvature on flat surfaces, and there are no flat surfaces on curved surfaces. They're totally different things. So you agree it looks flat. We agree too. How can we know it's not flat, that it's actually a ball? Narnia, right? Videos, right?
Okay. So with this kind of argument, we wouldn't actually be measuring the surface. We'd be measuring the water because, if you measure the surface, it's not going to be perfectly flat. But the argument that I guess for flat earthers to be convinced that the Earth is a globe is if we're able to, if globers can demonstrate a lake bending or having like a big water bowl that can bend, then we can have some faith in that kind of indoctrination again.
Yeah, 10 miles. You got to show us 10 miles. Have you seen the direct measurements, Fresco? Have you heard of the direct the laser test and all those?
The laser test, but no.
Well, to be fair, you don't need a laser, but like, how about like the, like the long distance photographs, like where you see mountains 300 miles, like, I think Indio has like there was a report where mountains were sighted at 300 miles and and that was at sea level and they were on a boat or something and it was insane. But they should be hidden by like, and by the way, in 300 miles there should be like miles of curvature blocking them, but they were fully visible. And we can show you those like we can show you the long distance observations. Have you seen any of those?
The only place.
Not the mountain one. I've seen the boat one. Someone show me that.
Okay, here. One second. Go ahead, Bong. I'll post them in live stream voice text. Are you in live stream voice text?
Not right now. Can be.
You can be. Okay, I'll ping you when I get them. Go ahead, Bong. I'll just ping you when I post them.
Yeah, nowhere. I have never seen or known or heard of any sphere or curved surface, right, in the real world that anyone has ever had to assume it was flat because it was so big. Like, the only place this idea exists is this globe Earth model that people have in their mind. 76% of the globe Earth is supposedly water, right? And we always observe water to be level and flat. We got sea level. So only when you think of this, right, will you say to yourself that a curved line or a sphere can appear or look flat. But this is insanity. This is irrational. Not even logic. It's not even math. It's some kind of crazy idea, all right? It's a lie. It's a straight up lie. The Earth is so big it looks flat. You can tell it's a ball because it looks flat. Like, who the hell thinks that? Only in this case do people think that.
And by the way, Fresco, have you heard of the... Oh, sorry, did you want to respond to what Bong said? Go ahead.
No.
Okay. By the way, have you heard of the Earth Curve Calculator?
No, I've never seen that.
You've never seen that? Okay. Okay, do you see live stream voice? Go ahead, sorry, what?
Is that a website with an Earth curve calculator?
They literally just it has like a form. Basically, it's you plug in a bunch of numbers. Like let's say you were to go outside and go to a place where you can see very far away, and then you take a photograph. Ideally, you would be like on a shoreline, and you could put like a mirror on the other side and see if you can see the bottom of the mirror. And so you can just put you put the observer's height. That's how high you are in feet and elevation, and then you put the distance to the target, and then you have the height of the target. And then it'll tell you how much you should see, whether or not you should see it. So basically, go ahead.
It gives you the curvature rate of any sphere or circle, based on depending on how big it is or its radius. So it's just an equation that tells you if it's this big, right, then it should be curving this much, and if it's curving this much, then you should only see this form. That's basically what it is. Giving you curvature rates of the surface of that sphere based on its radius. So the globe has a radius.
You talk a lot about what you can see at the horizon, which you shouldn't actually be able to see, but you're ignoring like all the like the refraction.
Okay, refraction of what? Refraction of what?
In the atmosphere.
Refraction of the curvature. Who measured the curvature to know that there's refracted curvature on the horizon?
It's not an argument.
What did you say?
That's not refraction. Is not an argument.
Hold on. Let's get an answer to the question. Who measured the curvature to know that there's a refracted curvature on the horizon? Why would you say that?
What do you mean? They're like...
Okay, you're saying that, we're seeing further than the curve should allow us to. That's because that curve is refracted to look flat. Who knows that and how?
Refraction.
Yeah, no, there's refraction. Is there curve though? That's the point.
That is not how refraction works, and we're not going to talk about how
it doesn't work. Right? She's still invoking the curve. She's still invoking the radius. She's saying, you don't see it. You see a hologram, argument. But it's there.
It's not her argument. She doesn't even know.
Hold on, dude. How do you know it's there, Fresco? How do you know that there's a refracted curve there?
She doesn't.
Well, let her answer.
So you want me to prove that the Earth is a curve before?
Yes, because you're still invoking it. You're still saying it's there, even though you don't see it. You see this flat horizon instead. So how do you know it's actually curved but distorted to appear flat? How would you know that?
Okay.
Okay.
Well, I don't know what to say. You want me to prove that Earth is
Because
curved?
you don't understand the argument you're making. That's why.
You can say there is no proof that there is a refracted curve. That's what you're supposed to say. Or not even supposed to. That is what the truth is.
Do you know what refraction is?
Begging the question. Go ahead, Bob.
Yeah, do you know what refraction is? How it works? Is when light. You know when you put a straw into a glass of water, right? And you look at the glass of water, you look at the straw, and like the straw looks bigger. Yeah, that's refraction. So it's you observing something change, through two mediums. That's not what's happening when we look at the Earth. This argument where people say refraction is made up, and it's not taught in school. It's not taught anywhere, because if you try to bring that up, you'll fail and mess up math and like mess up the calculus, whatever. It's based on the globe, on the Earth being a globe. It's called terrestrial refraction. Somebody made it up, and it's pseudoscience. So it's not even an argument. Yeah, I'm done. Go ahead.
Yeah, I was gonna go ahead, Fresco. You want to respond to that? I have another thing that I wanted to say, but go ahead.
Well, I disagree. Everything is made up.
With what? Refraction of a globe is made up because the globe is made up. There's no globe to refract, so that's definitely made up. Refraction exists. The thing that you say is refracted doesn't.
Yeah.
Can I also? Okay, so really quick. What do you think? What is necessary for refraction, Fresco? What do you think is necessary? Like, what are the requirements?
Some sort of substance,
like a medium.
Yeah.
Like gas.
It's like the bending of light.
Okay, so you need light, and what else? What do you need besides light?
Well, whatever the light is going through, like the
medium,
substance.
Right?
Yeah.
Okay, and in this case, the medium is gas, right? It's air.
It's our atmosphere, yeah.
Okay, so how do you prevent the gas from expanding into the? Okay, are you aware that in the globe model, they believe that the gas is right next to an open vacuum?
Like the levels of the atmosphere, is that what you mean?
No. The gas, the atmosphere is right next to a 10 to the negative 17 torr open vacuum with no physical barrier in between.
Yeah. It's like having your freezer open, but the cold air doesn't come out because some kind of magical force is holding it in.
Right.
Cold.
Like, are you like outer? Basically, here's what I'm asking. Here's what I'm going to ask you. Okay. Let me give you an example. Let's say someone goes into space. Let's say you're in a spaceship, right? And let's say inside the spaceship you have a bunch of gas, okay? You have a bunch of oxygen, right? And let's say you open the door. What happens to the air?
Might get sucked out.
Right. Or it not even, it just moves out. It just moves out, okay? Let's just say it like that, okay? The air goes out, right? Okay. So what do you think is, what prevents, or let me rephrase the question. Have you ever seen a demonstration in real life where you have gas like air pressure right next to an open vacuum and the gas just stays there and doesn't go in because of this thing called gravity? Have you ever seen that in real life?
No, I've never seen a demonstration of that.
Would it be the truth is nobody has and no one ever will, actually. If you can believe, Yeah, no one has ever seen a demonstration where gas pressure is next to an open vacuum and the gas just stays there. It's always like every single time it goes in without fail. If you put it next to a vacuum, that's 10 to the negative 17. Does that, you get what I'm saying?
Mm-hmm.
Right. So hold on. Wait, let me finish. So the Earth, right, is surrounded by gas, right? Or surrounded by the atmosphere. Now, what stops it from going? What prevents the air from going into the vacuum of space? Do you think gravity's strong enough?
Gravity. Take gravity.
I'll give you a hint. Yeah, say it. Say the word.
You want me to say gravity?
Do you believe
Ding,
it
ding,
though?
ding.
Do you believe it?
I know gravity exists.
Okay, so do you think? So do you think? Hold on. Do you think that the gravity is strong enough to stop gas from going into an open vacuum? 10 to the negative 17, Tor, by the way.
Yes.
Okay. Have you ever seen a demonstration of this?
No, I've never seen a demonstration.
What if I told you nobody has ever done that? And it's actually that's what this entire religion is based on.
The fact that you don't believe in gravity.
No, it's the fact that
I know.
In order to prove it,
atmosphere, and you don't believe.
No, it's in order to prove. Okay. Let me rephrase. Okay. If you were to prove, let's say you're trying to prove gravity, right? Because that's what it comes down to. So the gravity. Do you believe that gravity is dependent on how much mass the Earth has? Like relative to what if you dropped something like on the Earth? Do you think that the mass of the Earth has an effect on the gravity that object will experience?
Yeah.
I'm actually not sure.
Gravity.
Okay, define gravity? Hold on, define gravity then. Just define the word in your own words. Go ahead.
Gravity it's a force. And it like.
What does it depend on?
Well, it kind of does. I guess it needs something with a mass to pull it towards.
Okay, so it does depend on mass, right?
I guess, yeah, it does.
So you need mass. Okay. So wait. Hold on. Right, it's the theory. Right, I know. Hold on, I'm getting to that. Okay, so it's directly. Hold on. It's directly linked to the mass, right? Okay, so in this case, right, we're on Earth, so it's directly linked to how much mass the Earth has, right? Agreed, Fresco?
Yeah.
Okay. Here's the problem. No one has ever measured how much mass the Earth really has.
But that's
my argument. That's their problem. They need to prove it. No one has ever proven gravity.
You need to prove it too. You don't believe the Earth is a globe, so why don't you prove that?
Bro, you're not getting this. You're not getting this.
I am getting it. I know what you mean.
Listen. No one has ever measured how much mass the Earth really has. So there's no way that they know for sure that the reason why when things fall toward the surface, that it's because of gravity. They have no idea.
But obviously the Earth has a mass.
Well, hold up. So there's what the gravity you're thinking of, right, is an acceleration, right? It's the 9.8 meters per second square, number, right? That's probably what, like when pilots experience zero, how many G's, right? Like getting pushed down, right? That's what you think gravity is, right? That force, right?
Yeah.
Okay, if we're going to bother talking about gravity at all, which is kind of silly, we might as well talk about the claim in regards to gas pressure. So let's just ask her this. Do you know what the claim in the heliocentric model, what we're taught in school, about gas pressure and gravity? It causes
we already went through that. We just went through that. We just went through that, and the problem is, how do we keep air from getting sucked into the vacuum? And her answer is gravity. Right. That's her answer. So now
no one has ever demonstrated.
The tokamak reactor demonstrates that.
Next to an open vacuum, show me. Post it in the live stream voice text right now. No physical barrier. Hold on. No physical barrier. 10 to the negative 17 torr right next to gas pressure. Post that in the live stream voice text. Only using gravity. No physical barrier. Using right next to the open vacuum. Put gas pressure. Post that in live stream voice text.
Unreasonable.
No one has ever done that. No one ever will.
That is unreasonable.
Thermodynamics.
No one will ever be able to demonstrate that because
that's unreasonable.
He just admitted that his claim is unreasonable. For the record.
No, that experiment is unreasonable
because you can't prove
your claim is.
Well, that experiment is unreasonable.
Hold
because
up,
your claim is.
Lady that's listening is getting confused. We're trying to just simplify it first.
It's not a simple thing. You can't just simplify it.
Well, the thing is, why do things fall down? See, that's easy to explain.
No. Wait, Bong. You're going back to the whole, that's just a whole separate thing. Let's stick to gas pressure. So again, let's focus here now. There's the X value in gas pressure when we're measuring gas pressure, just gas pressure by itself. It's measured in the X value form.
Can I ask a question real quick?
So you take for instance, do you know what the X value is in your typical car? Your typical economy car, American economy car. You know what the X value is inside the tire? Tell me.
Can I ask a quick question, please?
No, come on, tell me.
No, there's a question standing at the moment. You can answer that one if you want to speak. Go
Come
ahead.
on, what is it? Come on, Mr. Smarty Pants. What's the X value in your typical economy car, your typical American economy car? What's the X value, PSI, inside the car tire? What is it? Tell me.
45 PSI.
Well, that's a little high, but 36 PSI to 45 PSI, yeah.
Depends on whether or not you have a low pressure.
Maybe your trucks might have 45 PSI, but yeah.
No, the smaller the tire, the shorter the tire, the higher the PSI. The taller the tire, the smaller the PSI. So it's your low pros are going to have the higher PSI. Your low profile tires.
What's her name?
Yeah, anyway,
can I ask you a quick question? Do you think that gas pressure is the same as atmospheric pressure? Because they're not the same.
Well, atmospheric pressure is not. No, they're not the same thing because atmospheric pressure is a fictional term. So gas pressure is a fictional term.
I mean, it's
a fictional term. It's like Harry Potter, Wingardium Leviosa. It's a fictional.
So why do you think that atmospheric pressure is fictional?
Because first of all, there's no atmosphere to begin with, so that's why.
What are you breathing?
Clear it up.
What do you breathe?
So here, buddy, listen. So atmosphere is technically a misnomer of a term. So atmo is Latin for air, and then sphere is a shape. Now, air is a gas, and gases have no inherent shape. Thus, atmosphere is a misnomer. It's a nonsensical term.
And that's why it's fictional.
See,
yeah, it's also fictional.
That doesn't make sense at all.
Yes, it does, Donald.
What's the name of the young lady that
gases have no inherent shape? He said it. It was clear. There was no
shape has nothing to do with whether you can breathe or not. Come on, guys.
Shit. So what is?
Yeah. Okay. Holy shit. Yes, I'm here now.
So what
the fuck are you guys arguing about? This is
this guy is claiming that
I was listening. Go ahead.
He's saying that gases take shapes like spheres and stuff, and O'Brien is addressing that. That's what's going on.
Oh, spheres! What spheres of air? No, we're not talking about spheres of air. Bong's not talking about that. What the fuck are you arguing about?
Okay,
what do you breathe?
We're talking about how gas and a vacuum can't be next to each other, right? And then she says,
"So you disagree?" So, who's she?
Right? So she says,
"You're just wrecking the conversation right now."
Okay. Yeah. So we're trying to explain to her what gravity is not.
By going for 5 minutes arguing with each other about spheres of gravity.
No, we're talking to Donald.
Yeah, but I mean, we kind of already talked. Like Donald's, I think, just going over BS he's gone over before. Like, let's just talk to this new person for a second. Like, whoever that was.
Sorry for the interruption.
I'm not new. I've talked about this a few times.
All right, but let me ask you a different approach. Let me just ask you a very specific question about this. So, you know what a greenhouse is, right?
Yes, like greenhouse gases.
Well, no, I'm not talking about greenhouse gases. I'm just mean a greenhouse, like physical.
Yeah.
All right, the structure type. So so some of these greenhouses that have been built before are airtight. You know, they actually have pressure systems inside them. All right, they're closed systems by definition, meaning that light and heat and energy can go in, but matter cannot go in or out of any kind. All right. So you're familiar with a closed system?
Okay, yeah.
All right. So let's say we got one of these greenhouses. Let's just go in a hypothetical here for a second. All right. You in the physical world. All right. You have a greenhouse 3 stories tall. Let's say it's sealed off. All right. And let's say you have a barometer to measure gas pressure, and you hold it near the floor of the first floor. And say it measures 16 psi, 16 pounds per square inch. And then you climb a ladder up to the ceiling of the 3rd floor. And you hold it near the ceiling. Let's say it measures 15.9 psi. So we've clearly established in this hypothetical that you're inside a closed system. You have gas pressure in the X value form, which is 16 psi at the ground level. And you have a gas pressure gradient, which comes after X, which is the gas pressure gradient above your head. The gas gets ever so slightly thinner as you go up. And you're inside a closed system. So as you step out of the airlock into the regular world and walk outside the greenhouse and walk outside in the regular world, you have 14.7 psi at sea level and a gas pressure gradient above that. So then the question I have for you is, as you step outside the greenhouse, what reason do you have to doubt that you're inside a container when you're outside the greenhouse?
Well, that's because of gravity.
So all right. So if you're going to say that, then the question I have for you is: you have a demonstration of gas pressure in the X value form due to gravity without a container.
Would it be all right if I asked a quick question?
No.
Yeah, it's no.
Do you want a demonstration of gravity?
Well, a demonstration of gas pressure in the X value form due to gravity without a container. Because if I had that, then I would know that such a thing can exist. But without that demonstration, it's only a mere blind belief on my part that such a thing can exist anywhere, along with anybody else.
Yeah, like the pressure of your car tire, but without the rubber tire, just using gravity to create that pressure. Are you familiar with such a thing?
I get what you mean. But how are you supposed to create gravity when you don't have a mass that big?
Well, that's the thing, is that the burden of proof is on their side. It's not on my side to disprove it. It's on their side to prove it.
Well, you can disprove it if you believe the Earth is flat.
Well, the
you
next
don't want
question
to disprove anything because you say that everyone else should not believe the Earth is a globe.
Look,
you should
you
try
can't
and
prove
disprove
it.
something.
None of this is about belief. None of it's about belief.
If you can't prove gravity, right, without having something that big, then why can't you prove gravity with the Earth? Look, we're standing on the so-called globe, right? That's supposed to have gravity.
But you don't want to prove anything.
They can't even demonstrate, right, where this force is that the Earth we're standing on is pulling down. They can't demonstrate that. You understand? Do you know why things fall down? Do you know why the helium balloon goes up? Do you know why wood floats in water but the rock sinks? You know why, right? Because the wood is lighter than the
Wait, hold on. Let's go back. Wait, well, hold on, guys. Wait, hold on, Bong. Let me interrupt for a second. Let's just go back to what I was saying for a second. So, I asked you the question, as you step outside the greenhouse, what reason do you have to doubt that you're in a container? The whole world is inside a container because we have gas pressure in the X value form outside the greenhouse. We have gas pressure in the X value form inside the greenhouse. We have a gradient, a pressure gradient inside the greenhouse. We have a pressure gradient outside the greenhouse. So your answer to me was gravity. And I asked you, can you demonstrate gas pressure without a container in the X value form due to gravity? And you said you can't collect that much material in one small space or something along those lines to create that kind of gravity. But I just want to point out to you that's a convenient part of their story that makes it unfalsifiable. So you see, it's just an excuse. Like, see, that's just an excuse, but it's not.
Everything that you just said just helped the entirety of everyone that's brand new to the topic. Orion, you just helped everyone understand that in a complete, concise way by bringing up all the segments of.
Is that she agrees? Is that you agree with us that you need a container, right, to have pressure? That's the good thing.
I didn't
now
agree
the
with
problem is, no, you do agree. You said it was gravity. That's what's creating the container. That's what's keeping the gas from getting sucked into space. Because that's the answer that you must say. Other than that, you don't have any. It has to be contained, right? So we agree that it has to be contained, right? We think there's an actual container up there. These people think that there's some force
So
called gravity.
you think we're in a container?
Right? Yes, we have to be.
Check this out. Check this out.
Of
Bottom line,
thermodynamic.
hold on, guys. Bottom line, do any gases come from outer space?
Yeah, but do you think we're in a container?
Do any gases? Hold on. Whether or not. Christ. All right.
You also think we're in a container because you disagree that gravity has to contain the air. Listen, this is the global.
What air? Do they come from outer space or not? Do the gases come from outer space?
Wait, Helio, you're messing it up. The globe Earth, says that the mass of the Earth is what's creating this force that's holding in the gas pressure that we need to breathe. In other words, you agree that the air has to be contained. It must be separated by something in order for the vacuum not to suck the air out. We agree, but we think there's a container there, and the globe Earth model says it's a force called gravity. See?
Okay, I hope you can hear me when I say this. I know for certain that we are inside a container because the necessary antecedent for gas pressure is a container. And we have gas pressure here.
What does it look like?
So the problem is, right? The problem is proving your container is there. Like, we don't have to prove it's there because we are breathing the air, right? But we can't prove that the Earth is curving, and we can't prove that gravity is a thing. Those are the problems with thinking like that. You know what I mean?
Yeah, like you said that the air was being held by this giant globular mass, right? Well, the first thing you would need to show for any of that to follow would be the globe itself, right? So we're back to that again.
Fresco, wait, let her respond. Fresco, go ahead.
Yeah.
What do you want me to respond to?
Can you admit that you can't prove gravity using what he described?
Well, I think you can prove gravity.
Okay. Holding gas pressure next to an open vacuum 10 to the negative 17 torr without any physical barrier in between, and the gas pressure stays the same. Post it in the live stream voice text right now.
I don't know. You want me to find something that proves gravity?
Not just proves. It's very specific. Gas pressure next to a vacuum with no physical barrier in between. Post that demonstration, real life demonstration, in the live stream voice text. That's what we want.
Or
your favorite one. You can go ahead and post there. Like some lemon candy.
I don't think
Here, guys, let's make this a little Let's make this a little more comprehensible. So like you have 36 psi around the rim of a car, typically, right inside the tire. So if you could demonstrate for us, if you could show us a demonstration of 36 pounds per square inch around the rim of a car without the tire due to gravity, caused by gravity.
Hey, Ryan, you know she can't do that. Why would you say that to her?
Well, it's Helio.
Well, you're gonna need a rim the size of the Earth, right? That's got to be her answer.
Please put yourself on mute,
Yeah.
Helio. Please put yourself on mute.
You're gonna need a rim the size of the Earth. Am I right, Fresco?
Mute.
That's gonna be your answer, right? Probably bigger because a rim is hollow, right? So you'll probably need a bigger rim.
Did she understand my question? Did you understand my question?
Fresco, did you understand his question? Unmute yourself.
You guys are scaring her, man.
She's not. She muted herself. Fresco, can you hear us? Can you hear us?
She made her decision.
Okay, she unmuted herself. Yeah, tell us if you understand.
She was signing
I
up
know
for
what
it.
you're asking.
Okay, repeat what Orion said. Repeat what he said.
All right, so you know how typically around your average car here in the United States, you have 36 pounds per square inch gas pressure around the rim contained by the tire, right? You're familiar with this?
Fresco, you there? Go ahead.
I'm listening.
Oh yeah. So you know how we have. Well, anyway, so I'm just. So I'm asking you, do you have a demonstration of 36 pounds per square inch around the rim of a car tire, around the rim of a car without the tire due to gravity, caused by gravity?
How would I demonstrate that?
So that's the thing. No, I understand why you'd ask us that. It sounds like we're asking you to perform Harry Potter magic. And so you see, it seems like a crazy thing to ask, but I just want to point out to you, this is the claim. This is the claim. This is what we're taught in school. We are taught in school that the gas pressure we're breathing here on the surface of the Earth exists due to gravity. This is what we're taught in school. So that's a positive claim. You got to understand this is an extraordinary claim because every example we have of gas pressure involves a container and a fixed volume, and a consistent X value.
I disagree. Go ahead.
The way I would do it, let me answer that question. The way I would do it is I would get So proton stars are so dense.
Oh God, motherfucker! Right? What the fuck are you guys doing?
Rim. Let me finish my answer. I would take a proton star and build a rim out of it, and it should be dense enough mass to pull the air.
You're trying to help her understand.
But why not use
like where did we just
what the fuck?
Where the hell?
The tire example and the proton star example. This is completely non sequitur, you motherfuckers. What are you doing?
You're supposed to be on mute, okay?
No,
Stop
I don't have to fucking be on.
Stop yelling. Okay, you're gonna need a rim the size of the Earth, or maybe bigger, because mass. Yeah, because rims are hollow.
So wait, Bong. You got to make sure while you're saying this to point out to her that you're making a joke within the paradigm of the heliocentric model lore.
Okay, that's.
I mean, she may not understand that. Do you understand that he's making a joke right now?
Well, a proton star. Yeah, never mind. It's not.
You guys should do
what's important is that you understand why things go up, okay, and why certain things go down in water and air is because of the difference in densities of the materials, which is why an apple falls down when it comes off the tree and a helium balloon goes up. Eventually, it will rest somewhere and find equilibrium, the helium and the apple. See? That's how things work. And there's an electromagnetic relationship, right? And the formula for gravity looks very similar to the formula for electricity, for this electromagnetism. And gravity really doesn't affect anything. Any other of the other fundamental forces. There's four. I don't think she understands all that.
You think, Fresco? What do you think?
Shouldn't explain it.
What do you think of all this?
I don't know. I feel like well, you guys
nerds,
don't believe in gravity, so I don't know what else to say.
Well, that's the problem. It's just a belief.
So you don't understand what gravity is. We want to know that, not believe.
Yeah.
Yeah.
Where did it
it's in the wording that you used right there. It's just a belief, I guess.
Guys, one at a time. One at a time.
I was going one at a time. It was just me.
Gravity is not used in any profession, or the only place you'll find it being used is in theoretical sciences. You know, guys that sit around and look at numbers and guess, you know, how they simulate things. They don't work with anything real, right? So nobody uses gravity. Electromagnetism is the only thing that people really use. All this technology we have today is built on electromagnetism.
I think dumping information on her will be mostly ineffective, and we have to just kind of figure out where she's coming from, where she's at, what thoughts she has, and just take care of those.
Yep.
I disagree. Dump away.
Because if you don't understand gravity, right, then what you have is a faith. You know, you have faith in people. I used to have faith in people, of course. Why would scientists lie? They're trying to help us, right? Well, I used to think the medical industry was there to look after my health, right? These are doctors. You know, my uncle is a doctor. My cousin's a lawyer. You know, right? That's not how their professions work. I asked them, right?
Hey, check this out, guys. I figured out like 20 minutes ago that she had a basic understanding of gravity that we all used to think was gravity, and she's kind of confused now. And you guys keep bombarding her with information that she can't understand, and it's really confusing to not only her but a lot of other people. And so that's why I was jumping in, you know, trying to, you know, help anything. Yeah, but and then you muted me because I was yelling because you were being stupid.
Donald C came in, and that's when you know, it kind of started getting rough.
Went off the rails.
Yeah, went off the rails because you were freaking bringing up stupid arguments to someone that's ignorant, didn't know anything about it, and you were just like, "Here's gravity," and then you were bringing up other arguments that really had nothing to do with the gravity at all.
What do you mean by you?
You, Orion, and you, Bong, were bringing up stupid arguments that really
I'm not Orion, Helio. Figure out what
not you, heretic. Not you, heretic.
Mute yourself, okay? You're the problem.
Oh, I'm the problem. Okay.
Yeah, you're the problem because I said so.
That's good enough for me. I'll give you that one.
Well, how does it feel?
How you doing, heretic?
Well, I'm struggling through it here too. You know.
Well, it's just like they're talking to this, this girl is just like, okay, they go through 20 minutes of explaining all kinds of shit that we understand, but she doesn't know what she's talking. Listen, I'm not saying she's ignorant. I mean, she is ignorant, and we were ignorant about a lot of this.
We've been dumping information on her.
She's ignorant, you know what I mean?
Yeah.
Shut the fuck up, man. We're trying to talk to her, Helio. God damn it. It's fucking embarrassing. Fresco, what's up? How are you? Still there?
She's gone. She just dipped.
No, she dipped like 5 minutes ago, and you guys didn't.
No, she just did, just this second.
Just now.
Right when he asked her what's up.
Spartans! What is your profession?
See, old friend, I brought more soldiers than you did.